Class 11th, I will tell you about the motion of a vehicle on a circular road. And this will take the plain circular road. And first we will find that when there is no friction between the road and the vehicle, and second, when there is a friction between the vehicle and the road. So first we are taking that there is no friction between the vehicle and the road. Let R equal to radius of circular road, V equal to velocity of vehicle and the mass of vehicle, and let consider that no friction acts between wheels of vehicle and road. It means that road is perfectly smooth. So we are having this a circular road. This is now suppose the center, and that this is the radius R, so much. This is a vehicle, this is the vehicle. The force, reactional force acts just perpendicular to it, and let it makes an angle theta with the vertical, so it can be resolved into two components. This is now R cos theta, and second is R sin theta. There is the centripetal force mv square upon R that acts towards the center. Forces on the vehicle. Number one, weight. And vertically downward. So here we have the weight. This is now weight mg. Second, normal reaction R. Vertical to the vehicle. and third the centripetal force. Force mv square upon r towards center of circle, towards center of circle. So r can be resolved into two components. One component is the r cos theta and second the r sin theta. So here this centripetal force is provided by this r sin theta. Normal reaction. Makes an angle theta with the vertical. The components of R कौन कौन से हैं? Now one is the R cos theta and second is R sin theta. So this component R sin theta provides the centripetal force and this component is balanced by the weight of the vehicle. So in equilibrium, what we have? This r sin theta equal to mv square upon r and this r cos theta, this is equal to mv. So these are the two equations of motion for the vehicle on the circular road. And now if you divide them, so now we can have this r sin theta upon r cos theta equal to mv square upon r into mv. Here m and m cancel, here this r and r cancel. So this is equal to tan theta equal to v square upon rg. This means that this theta equal to tan inverse v square upon rg. So if suppose there is a vehicle moving on the circular road, then it must have so much inclination with the vertical so that it could move safely on the circular road. It is the inclination. That vehicle must make with vertical for move safely. If suppose we are having this theta to be 1, this tan theta is equal to 1, then theta is equal to 45 degree. In that case, the velocity will be equal to square root of rg. So if suppose if tan theta equal to 1, then v equal to square root of rg. If tan theta is not equal to 1, this means that theta equal to 45 degree. 45 degree. So if this theta is not equal to 1, then definitely we will have the velocity of this v equal to 10 square root of r tan theta. So velocity of vehicle, this v equal to square root r v 10 theta. This is what that we have considered the road to be a plane and there is no angle, there is no banking in the road, and also we are considering that there is no friction between the vehicle and the road. So road is taken to be perfectly smooth. Only in that case we are having to this so much, and this should be the velocity. This should not exceed the velocity beyond this one, because if this is so much, then the vehicle will escape on the road. So this is the motion of the vehicle on the circular road. So this is what that we have to this one. If suppose there is a force of friction, let's mu equal to coefficient of friction, then the frictional force this Fr equal to mu r. So mu is what? Mu, and r that will be now your this r cos theta. Now, when this friction is acting between the road and the vehicle, then this friction force provides the necessary centripetal force. The friction force provides the necessary centripetal force. It means what? That this mu r must be equal to the frictional force. So what we have that for if mv square upon r is less than mu r, then the vehicle will not escape and it will move safely, and it will move safely. If mv square upon r is greater than mu r, then the vehicle will escape. Vehicle will escape and it may fall down towards the center. And it may fall down towards center. So it means that suppose if there is a two-wheeler, then this will, suppose this snake is turned towards the right, then this will skid, the vehicle will skid and the rider will fall towards the center. And if suppose there is a four-wheeler, then what will happen? There will be the something different situation. If a four-wheeler moving on a straight road takes a suddenly a U-turn towards the left or towards the right, then the inner wheels will be lifted up, and so it will take the turn towards the away from the center. So suppose this is now four-wheeler and this is taking a turn like this one, then these wheels will rise up. So this will be like this, and then this will take a turn like this one. So this is what, that when we are taking to this one, then the vehicle will skid, and this will, in case of two-wheeler, this will towards the center. So now we are having this for safety driving. So what should be there? Else. ME square upon R must be less than equal to mu R, or ME square upon R. This is for safe riding, for safe motion. MB square upon R, this is equal to mu R, or we have this MB square upon R. This is now mu, and this R is equal to mg. There it is having no banging at all, so this m and n will cancel, and therefore this V equal to square root of mu R. This is the minimum velocity. Minimum safe velocity. It is velocity required to move safely. So if V is greater than this one, then the vehicle will, like this, we are having this one, then the vehicle will skid. If V is greater than square root of mu Rg, the vehicle will skid, and if V is less than equal to mu Rg, it is safe. It is safe to move. So this is so much minimum velocity is to be maximum velocity should be there. And what happens that when a vehicle is moving on a straight road and it takes a turn, then either this reduces its velocity so that the radius of the circular path is reduced, by means of which this v will be less, and also this you can see that this mu plays a very important role to avoid the escape of the vehicle. So this is what I have told you, that when a two-wheeler or three-wheeler take the turn, then what happens there when it is taking the turn towards the right or towards the left. So this is the motion on the plane road. So thank you very much.